Cool, okay. So hello everyone online and present. Welcome to the Advanced Tidal Workshop. So I'm not sure how much familiarity you guys have with TidalCycles, but I watched the mini Tidal workshop that David gave earlier this week, so I have an idea of where you're at, if that's what you've seen. So I thought I would just sort of do a quick overview of what you went over a couple days ago, and then we'll jump into extending some of that stuff. And for this workshop, we're going to be using Extramuros, which is it's a simple web application that takes the text in these boxes, and then when you click eval, it'll send that code to my computer to render the TidalCycles code, and this way we can get coding quickly without installing anything. So I'm just serving this locally. So if you're on the Max Secure Wi-Fi, does everyone have access to that? I'm on EduRoam? Okay. Luis, did David give Max Secure Wi-Fi code?
I got one.
He gave me one, but it didn't work, so I tried the other one.
Okay. Just because we need to be on this network for people to access Extramuros.
Yeah. He had a big page of passwords.
Okay. Sure. Or I could give you my computer if you like my other one. So if you're watching online, obviously you won't be able to get to this website that I'm hosting just in the space. So instead you could follow along using Estuary, which is this URL here, intramuros.mcmaster.ca. I'll blow that up for you. Once it's loaded. So if you can get into the Wi-Fi, okay, yeah. So I'll show you the URL in a sec. But for anyone joining online, if you want to follow along and you don't want to install anything, if you can go to Extramuros at this URL and go to solo mode, and then everything we're talking about here you can write in one of these mini Tidal boxes. There are some things that might not work in mini Tidal. For this workshop, I'm using sort of the newest version of TidalCycles, and mini Tidal doesn't quite yet support that because it's kind of a moving target, and the Estuary team hasn't fully caught up with those moving targets. So I'll try to warn when that's the case, when it might not work in Estuary. But yeah, for everyone here, if you navigate to this URL,
Okay.
And did you get the same interface?
Yeah.
You see this?
Password?
NIL, the capital N, I believe. Oops. Actually, I'm just going to double check.
Yeah. It's working.
Capital N?
Yep.
Capital NIL. IL. Just as I've typed there. And then, yeah, just type that in, hit enter, and it won't tell you anything, but you should be good. So if you want to claim a box, I'm going to take maybe this first one and just put 2 dashes, a space, and then your name or something to identify yourself. That's fine. So I think when you were using mini Tidal earlier this week, you just started your patterns by typing something like S, and then the name of a sample, and the name of another sample, and so on. In this interface, there's one more step before it. We have to do a D, a number, and then a $sign. And this D basically just identifies, me in this box, I have access to D1. So no one else use D1, because then you'll overlap with what I'm doing. So choose another number. So Alex, you could be D2. Alejandro, you could be D3 if you like. So picking up from where we left off earlier this week, we remember when we type things into a pattern like this, the pattern gets evenly divided. Oh. Not getting sound, 1 second. That's strange, sorry, one second. Sorry, it's NIL lowercase, NIL. So if you typed uppercase, just enter that again into the password and hit enter.
The lowercase.
Yeah.
NIL? Is it
Yeah. So yes, okay. So picking up from last time, if you take a bar, you split it. So I put one sample in there, so that sample is getting the entire cycle, or bar if you want to think of it as a musical bar. If I put another item in it, like a snare sample, then the bass drum gets half, the snare gets half, and so on. You can subdivide parts of the cycle by putting things in square brackets. So if I put square brackets around this snare sample, it will sound the same, but I can put another pattern within this. And I can put as many things in there as I want. I'm not sure if this was mentioned before, but you can also put a rest with a tilde. So no samples triggering, that's just a rest. We've also showed that if you want to play, so if I want to play two of these sort of hi-hat samples on the same second half of the bar, I can put them in an enclosed square brackets, or I can multiply them by 2. Those are equivalent. If I do 3, then it'll play 3 in that allotted time. Similarly, there's a divide operation where if I put divide in a number, then it will slow that down. So now the hi-hat sample will only play every other cycle.
I'll say this before I switch the mic over. Sorry, I forgot to do that audio change that I was doing before I came down. So everyone on the stream has been hearing your direct audio, but not your voice the whole time.
Oh, okay.
So I'm going to switch that over.
Okay. Yeah, we didn't.
I hear both on the stream when you.
You hear the voice?
Yes.
Really?
Because I checked. Yeah, because.
Oh yeah, I see that. Oh, did you turn it up? Alright, never mind me. That'd work.
So yeah, if I put divided by 2, then it will be every other symbol, every fourth, and so on. Something that wasn't shown, I don't think, in the last session was if I put a question mark next to the sample, then there's a 50-50% chance as to whether that sample will trigger or not. Similarly, I can apply that question mark to a sample that I've multiplied. So this will play 4 times, but only for 50% of the time. So if I play it, so some of those 4 hi-hat samples are being
Each
triggered.
hit has a 50% chance.
Yeah, exactly. Each hit has a 50% chance. So everything I'm showing here can also be applied to things in square brackets. So I could put, instead of 2 hi-hat samples, I could put a hi-hat and a snare. Maybe I'll take away the question mark just to make that a little more. So you can get pretty complicated even just with these little things. So we also showed last time that you could combine patterns. So this is a pattern of samples, but with this hashtag or whatever you want to call it, I can append a different type of sample. So maybe I want to append a different type of pattern. So maybe I want to change the playback speed of a sample. So there's a speed pattern. If I put it at 1, it'll just sound the same as what we were hearing. If I put 0.5, it'll play it at half speed. If I play it double, and you can play it backwards too, with negative numbers. And everything in here can also be put in square brackets. You could make it play both forward and backward at the same time. Since this is also a pattern, I can give it more arguments. And I'm going to make this a little bit more simple to show how this is changing. Okay, I'm not going to get into that quite yet. So right now, because this S pattern is the first one, it comes before the speed. And if I put another thing like a low pass filter, the number of things that are triggered is entirely dependent on this. So there are 4 items in this speed list and in this speed pattern, but we're only hearing 1 bass drum per sample, or sorry, per cycle. That's sort of a feature of this operator, but I'm not going to go into that in too much depth. So if I had a clap here, actually I'll put another bass drum. So what we're hearing should be the bass drum played at 1 speed, and then the second one played at 3 speed. Okay, so I think that's sort of enough review of what you guys did the other day. I'm going to show you a few more of these cool pattern notations that we haven't covered yet. The first is you can make a Euclidean rhythm by using parentheses. So a Euclidean rhythm, if I give this 2 numbers, say a 4 and an 8, it will divide the cycle up into 8 pieces, and then evenly distribute 4 bass drums along those 8 pieces. So we're hearing 4 equally distributed bass drum things. Now we're hearing 3. It's sort of more noticeable if you do it with other things. So I'll do a hi-hat. I'll also do 8. And again, you can get pretty complicated rhythms just by Are there any questions so far? Okay, so there's another notation that makes it really easy to do polyrhythms, which is this curly bracket notation. So these curly brackets, if I put my bass drum clap pattern here, and then a comma, and then another pattern. Maybe I'll put a hi-hat, and then a different type of hi-hat. How this will render is, again, the first pattern that you see in the list here will sort of determine. Actually, it's probably easier if I just play it. So this bass drum will play at the same time as this hi-hat sample, and then this clap will play at the same time as this hi-hat, and then this will cycle back to the bass drum, and then this longer hi-hat sample will play, and then the clap will play again. This will loop back to the hi-hat. Does that make sense? I'm not sure I've explained that super well.
Is the comma the one, the comma divides the cycle in 2?
In this case, it doesn't divide it in 2. It's sort of separating this pattern from this pattern. So this pattern is determining so if I put another element in this, so this pattern indicates that since there's 2 elements in it, each sample we hear will get half of the cycle. So we hear the bass drum on the first half of the cycle, and then the clap on the second half of the cycle. This hi-hat will also get the first half of a cycle. This hi-hat will get the next half of the cycle. And then there's a third element in this pattern. So this different hi-hat will get the first half of the next cycle. There's actually a good visualization of this on the website, which explains it far better than I'm verbalizing it. Oh, I thought there was. Actually, sorry, I thought there was a diagram there, but there isn't. So maybe it helps if I type it out. So cycle 1, we'll get. So on the first half of the cycle, we'll get a bass drum and a DR sample. On the next half, we'll get the clap and a DR sample. And then we'll be on to cycle 2. And we'll get the bass drum and the different. And then we'll get the clap and the original. So this lines up with this lines up with this, and this lines up with this. Does that make more sense? Okay. Sorry, I'm not sure I explained that super well. And then you can put arbitrary as many patterns in here. So maybe I have another sample, and I'm just going to put it once. So we hear the same one each time. And you can put rests as well. And if you put sort of an odd number of things in each pattern, then they'll only repeat at the multiple, or sorry, not an odd number, a prime number of things. So here's 3 and there's 5 in this one. The pattern will not repeat very much because it'll only repeat at the multiple of those prime numbers. So that's the strategy some people use in live coding, using prime numbers for things to have these sort of long unfolding patterns that aren't too repetitive, but maybe sort of find the nice balance between repetition and difference. Any questions so far? Okay, so I talked before, so go back to a more simple pattern. Let's use something that's pitched, and we'll play it 4 times. Oops. So again, speed will change the playback speed of the sample. So if I put 2 in here, we hear a pitch change because that happens too when you speed up the playback speed of things. But so the only patterns we've seen so far have been things inside quotes, but there's other ways we can specify patterns. So there are a few sort of convenience things. The first I'll show you is sine. Actually, I'm not going to use speed, sorry, I'm going to use gain. So this will control the volume. So if I set the gain pattern to just be sine, I'm going to play it more times. So sine here is a pattern that oscillates between 0 and 1. So instead of having to write out, a pattern that's 0, 0.25, 0.5, 0.75, 1, sine gives me a sine wave between 0 and 1. There are other ones like a triangle wave instead of a sine wave. I think there's also square. There's saw, which would just be like a linear up and then a drop. But often we don't want something that's just between 0 and 1. That's not always super useful. So if I go back to my speed example, I do sine. Getting some pretty low notes there, but I might want it to be something a little bit higher or in between a different range. So Tidal gives a function for that called range. So if I put the sine in brackets and then before it I can say range between 1 and 4, and then give it this sine. And the same works for all the other things I showed you, like saw. So this kind of thing can be, right, so I can't remember if you covered this before, but often we want to slow or speed up a pattern, and you can do that either with this sort of multiplication symbol, or before the pattern you can say, oops, fast, and then give a number, what multiple you want to speed it up by, or you can give it slow. So if I play, just the regular pattern, and I slow it by 2, or I can speed it up by 2, or 4. Or if I give it a fraction, then since it's speeding it up by a fraction, it actually slows it. So this is slowing it by 4, or slowing it by 2. So if I'm going back to this range thing that I was showing you, it's going between 1 and 4 according to this saw, but it's doing that every cycle. So maybe I want it only to go between those numbers over a duration of 4 cycles. So before this, so everything here is giving me a pattern which I can slow. So if I put this in brackets and then type slow 4, then it's taking longer to do that pattern. What you'll see often in Tidal is this $sign, which is a little bit tricky to explain, but often it's, instead of writing brackets around something like I did with the range 1-4 saw, instead of doing that, I can write a $sign, and what that's sort of saying is this slow 4 thing is expecting a value. It will take the value of everything that follows this $sign, so everything here. So it's kind of like a syntactic synonym for putting brackets around something. It's not quite that simple. There are some cases where you can't do that, or there's a different meaning, but for our purposes, that's probably fine. You can also speed these up, of course. So I've just showed you this for speed, but there's lots of other cases where you might want to use something that's interpolating between values. I use it for filters a lot. So if I want a low pass filter, I can slow a range between, say, 300 hertz and 1000 hertz in a sine pattern. Maybe I want to go lower than that. Does anyone have any questions so far? Cool. All right. So I'm going to talk about pattern transformers now. We've already seen one, which is this slow thing, but I'm just going to simplify the pattern a little bit to our bass drum clap. So there's a bunch of things in Tidal that can take this pattern and apply some transformation to it. So it's probably easiest if I show you. If I want to reverse a pattern, there's this thing called rev. and it'll play the pattern backwards. I'll make that a little more clear. So it's playing the hi-hat, the clap, the snare, then the bass drum, as opposed to the other way around. There's also brack, which makes it like a breakbeat kind of. Looking off my cheat sheet here. There's palindrome. Oh, it's N.
Missing an R.
I always forget how to spell palindrome.
Yeah.
So it plays the pattern forwards first, and then on the next time, it plays it backwards. So it's like BD, clap, clap, BD, over 2 cycles. There's also sometimes, okay, so another one I really like is iter, I-T-E-R, and you have to give it a number. So if I do iter 4, actually, I think there's so how this will translate is in cycle 1, I'll get bass drum, DR, clap, DR, and then I'll get DR, clap, DR, bass drum. So it shifts every cycle, and it'll do that 4 times. Oops. So sorry, these are all different cycles. So that's a really quick way to get some kind of instant variation. If I just did 2 here, then it would be this on the first cycle, and then on the next cycle, I believe it would be clap. And then it would just repeat these 2. Is that what we hear? I'm a bit rusty on this, but it's to that effect. So often we don't want to apply whatever effect we're doing for each bar. Maybe we want to do it every second or third cycle. So if I reverse my pattern here, maybe I only want to do that every 4th cycle. So I can do every 4, and then I can give my pattern transformer there. So I could have put other things in here as well. I could have done this one, fast 4. So this is one of the cases where I could not have used a $sign. This wouldn't be valid. The reason being, what this would equate to would be like putting brackets around this entire thing, as opposed to just around the next thing here. So here I have to use brackets.
You have to have at least a sample in a cycle, because if you did every 2 for the rest of the line, like you wouldn't have a sample, right?
Yeah. So it's yeah. So if I I'll just get that back. Oops. Yeah. So this isn't really syntactically valid to Haskell because every 2 is expecting something of a certain type.
Oh, Okay.
That thing it's expecting is a pattern transformer such as fast 4 or rev or iter. But what we're giving it here is a pattern that has been sped up by 4. So that there's a typed mismatch.
Oh, okay.
Or I can slow it down. Another handy function that's similar to every is called whenMod. And what it means is, so I've put 4 and 2 here. I'm a bit rusty on exactly the modular. So over 4 bars, 2 of those bars will have this effect applied to it. So if I run it, we hear 2 bars without it, and then 2 with it. If I do 4 and 3, then we'll hear 3 bars without the effect applied, and then 1 bar with it. So because 4 and 3 differ by 1.
Oh, is it modulus?
Yeah.
Right, okay.
I'm not sure why we're getting that distortion, but it's kind of cool. So you can put, yeah, any 2 numbers here, with this one being larger. Any questions about that? Sorry, I'll hush it. Cool.
So it's not proper modulus then, so because that would be 0 if it was like 3 mod 6, right?
Yeah, so it's something to do with the cycles, and there's like a count on what cycle you're on, and it
Okay.
uses that.
Yeah.
Sorry, I'm a little bit rusty on
Oh.
exactly.
Modulus is like when you, if it's x mod y, then it's like
Like the remainder.
result is the difference.
Yeah.
Basically, how many times you can divide y by x.
Right.
Something like that.
Yeah, like the remainder of an integer.
Yeah.
Yeah. So maybe I've been talking for a while, and I think we should jam soon. So I might just quickly show a few more of these, and then we can hop into a jam.
Sure.
And then we can pause a jam and discuss more if you have questions, or we can do whatever. Another one that's really fun is off. So you give it a number, which is a portion of the cycle, so a quarter of the cycle that I'm giving it here, and then you give it a pattern transformer like rev. And so what this will do is a quarter into this cycle playing, it will overlay the same pattern reversed. So actually I'm gonna do something that'll be a little easier to hear. So we're hearing that pitched up version of this an eighth of a cycle after this has started. So we're hearing,
That's great.
yeah, it's pretty cool. And then if that diagram makes any sense.
Yeah. Starting at 1/8 into the cycle, the
Yeah.
pattern starts playing at twice the speed.
Yeah. Something I hadn't shown you before was, so before we used this like hashtag and another pattern name sort of after this sample, but we can also use this as a pattern transformer itself. So again, maybe we don't want to speed it up by 2 every cycle. Maybe we only want to do that every other cycle. So I could do that by putting every 2 and then in brackets. And then I can get rid of this one. Any questions?
Can you bring that back for a second?
Oh yeah, sorry, I shouldn't have deleted it.
Yeah, you can put the speed modifier before or after.
It's important that this is in brackets though. Again.
Right. Otherwise, every function wouldn't be getting the right type of argument.
Yeah, exactly. I think I'll just show one more and then we can get to playing around. And I'll type in the notes section below here some of these so you can remember and use them when we're jamming. Stut is a fun one. Stut takes 3 numbers. The first, so it stutters the sample that you hear. The first sample, or the number it takes, is the number of times you want to hear it. And then you give it some probably decimal value that's the volume of each, the proportional volume of each subsequent sample. So the first sample will play at full volume, and the next one, if I put 0.5 here, will be about half, and then so on. And then you give it a duration, I believe in cycle, like as a proportion of the cycle, between each subsequent stutter. So I put 0.5 and 0.33. So each cycle we should hear 3 bass drums getting quieter. I'm not sure why we're getting that distortion. And that'll apply to all samples. And then one final cool thing. So I've typed all these as sort of static numbers, but these are also patternable. So instead of just writing 8 here, I could have given it a title pattern like we do with a sample. I could say we're only hearing the 2, but if I use these angled brackets that Dr. O showed the other day, then on one bar it'll play with 4, and then on the next bar it'll play with 2. So we can, pretty
How come
complicated.
without the angled brackets, when you just had 4 and 2, we were only hearing the 2?
I would have expected just to hear 4, to be honest, but yeah, let's go back to that. Okay, so when just just as a reminder of what Dr. O showed with those angle brackets, each item I put in these angle brackets gets a full cycle. So if I put bass drum here and then clap here, one cycle will get bass drum, next I'll get clap. Whereas if I got rid of them, then this cycle gets split into two. Bass drum gets the first half, clap gets the second. The same goes for this stud. So as is, the first half of the cycle would get a stutter of 4, and then the next half of the cycle will get a stutter of 2, whereas with the angle brackets, we hear cycle 1 with 4, cycle 2 with 2. I'm not sure exactly of the behavior when, sort of in this case, I only have one sample playing. So what happens on the second half of the cycle? Yeah, I'm not entirely sure of that, but I'm not sure exactly how this 2 gets applied. Okay. Any other questions? I would encourage you to also look at the TidalCycles documentation, which has more of this stuff. And yeah, we should jam with it a bit and yeah, make some noise.
Sure.
Cool.
You want it to be the jam?
I think we can. I think Dr. O's been cutting it, hasn't he? Or has he kept it?
We haven't streamed. There haven't been any jams.
There was a mini title one.